Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. Knowledge is power, now more than ever.
Hello, everybody. This is Sean Martin, and you're very welcome to a new episode of Redefining Cybersecurity here on ITSP Magazine, where we talk about how to operationalize cybersecurity in all types of businesses and shapes and different sizes all over the world. Each has their own unique way of looking at risk and how to mitigate risk, and oftentimes we turn to technologies and look for ways to help our people do a better job at protecting the business and the revenue that they generate. And lots of risk in today's digital world. One seems to be growing in popularity in the world of cybercrime, and that's the area of fraud. And it's not a new concept. We've seen it for a long time, and it's certainly not new in terms of cyber either. But perhaps the methods in which organizations are attacked have changed, and certainly the way that we need to look at protecting ourselves and battling these attacks certainly have changed. And Marco, my co-founder, and I often say that technology isn't going to save the world. The humans have to create the technology and use it to save the world. But certainly technology does play a role here, and we're going to talk about that specifically around AI, and we'll look at how AI perhaps can help fight fraud and maybe I suspect is being used to generate fraud and conduct fraudulent activity. So I'm thrilled to have a great guest on. I think, Jem, we met online on social media. I think there was a post that you made that triggered some interest from me, and
Awesome.
and thanks for being active on social media talking about this stuff, and more importantly, thanks for joining me here today on Redefining Cybersecurity.
Thank you very much indeed.
And let's give our audience a view into who Jem is and what you're up to, and why fraud is something that you're interested in talking about today.
Of course. So I have been in B2B tech for the past 20 years now. Started out as an engineer, then switched over to the consulting side. I was at McKinsey for about a decade. Then I was on the enterprise side, buying technology solutions. I was also on the vendor side, selling B2B tech solutions. And at AIMultiple, we sit in the middle as an industry analyst. We help enterprises pick the right technology solutions for themselves using vendor data. And fraud is quite an important area for me because a significant share of my time at McKinsey was spent serving banks. And this was back in the day. And there are various types of fraud, and we will get to other types of fraud, but banks are probably one of the largest spenders when it comes to dealing with fraud. And back in the day when I was working at banks, these global institutions, they had hundreds of people looking at potential cases of fraud across their operations. And, this could be, of course, in various stages in the process. It could be at the know your customer stage, or it could be about a customer's transactions and so on. And to tell a bit of the story of how things evolved, in the beginning, we had sets of rules, and these were guarded quite well. In short, people tried to keep their rules a secret and use them to identify fraudulent transactions. But of course, over time, the criminals learn about rules as well, and then they start to not get detected by the current rules, and then you add more rules on top, etc. And what you end up.
And when you say rules, are these business process rules? Are they transaction rules? What are the application rules? What are they?
So it depends on the specific context. So when we look at transactions, it could be leveraging the network, like how similar two nodes are to identify whether these could be fraudulent. Like you could say that if it's a new transaction from an entity in another country, and if the country is a high risk country for you, then you should be flagging it. And these approaches are, of course, quite. Their problem is creating lots of cases where actually there is no fraud. That's why you needed these hundreds of people to look at cases individually, because even when a rule triggers, most of the time that is not a fraudulent case. And that has two problems. First problem, of course, you are spending a significant amount in an operational work that is not really value adding for your business. But then you are also not catching enough of the fraudulent cases. That's because there's this phenomenon in human psyche where as we are exposed to input that are not really changing. So let's say the default case that you get is not a fraudulent case. And then you get into this mindset or this psychology of doing the default because it is true most of the time. But then you end up missing the important fraudulent cases. So in short, you end up, as an institution, you end up spending quite a bit, but as a result, the fraudulent cases still manage to get through your systems. And of course, over time, the maintenance of rules becomes another challenge for you, because you have this complex set of business rules, and most of the time they are not so well documented. So you have another layer of complexity, let's say. And we haven't discussed the types of fraud much. Before going into the solution, we can also start to discuss that a bit. As I mentioned, banking is definitely an area from the time you onboard a customer to the transactions of that customer, whether these are transfers or whether this is a customer taking credit out of your bank. All of these are subject to different types of fraud, and there is different terminology around it, and there is also different expertise around it. But banks are definitely not the only place where this happens. Pretty much any payment actor is dealing with fraudulent cases as well. And for example, the payment providers, credit card companies, e-commerce companies, these are all dealing with payment fraud.
And gift card companies, right? Even points, loyalty card companies as well.
Definitely, and also not just specific to the financial system. Ad fraud is another large area where companies are burning hundreds of millions, getting no value for their business while paying these actors that perpetrate fraud. We were recently talking to a customer, so they were getting ad fraud. This is a B2B technology company. They are getting these clicks through search that do not really belong to their target market at all. It belongs to their competitors clicking their keywords through some machine-generated approach. But it doesn't stop there. These bots are also leaving leads, trying to act like buyers, in short, attempting to waste the efforts of the tech vendor. So in short, even in domains like advertising, this plays a big role, and not just in reducing the effectiveness of your advertising, but it can also impact your sales efforts as well. So
I'm going to pause you, because it made me think of a use case here, since we're talking about different types of fraud, and this may be way out there. But I'm thinking about organizations. We use a few services that have an open portal to recommend new features or address bugs, and you can upvote and downvote and all kinds of funny things. And so you just mentioned a competitor using click fraud to presumably get their competition to spend money that will obviously take funds away from other activities that they can invest in. And I'm just wondering, have you seen any cases where feature fraud, so these feature request forms being misused to get companies build stuff that users don't even want, really? There's some bot or some competitor said
That would be a creative case. I mean, not specifically this, but as you know, social media, bot activities on social media, you can see them as fraudulent. I mean, especially if you consider cases like how they are impacting elections, and I mean, it is a bit like an extension of that activity. In short, mispresenting your audience's reactions, so you are following the wrong direction. And of course, these could be targeted against businesses. These could be personalized to shape my perception. And when it comes to these domains, of course, tools like okay, I have to mention generative AI here. I think pretty much in every in every discussion we have to mention it somehow. And yeah, I mean, having stronger language capabilities makes these bots pretend much better to be human, and then of course shape the decisions of whether it's people or whether it's businesses, to shape their decisions in the way that they want. So there is definitely expanding applications in different domains.
So I don't know if we can pick a couple examples to help illustrate how a fraud event works, right? Why does it work? You kind of alluded to, in some instances, people's brains work a certain way, and then we get into you didn't say rut, but we get into a rut for how we look at things, and some of those things might seem normal, and they might be actually fraudulent. So I'm wondering, can you kind of go beyond that a little bit and just talk through maybe who some of the actors are, the tools they use, how they target certain entities, kind of how that process flows before it hits the business, so we kind of get that part of the picture.
I see. It really depends on the domain, though. So, are we thinking about something like the social media that I mentioned, or is it more in the banking domain, for example?
Maybe so. I don't know. We haven't talked about healthcare. What kind of fraud might we see in healthcare? I don't know.
Insurance fraud. That's definitely a big domain. So, what we are seeing here is, in short, insurance companies being overcharged for the therapies that their insured patients have been subject to. And this can be there are various estimates on how large the size of the market is. But in short, what ends up happening is that you have this document that explains in detail what has been done to a patient using specific codes, and that doesn't reflect what has happened in reality. And as an insurer, this is quite hard for you to verify, because you get this document from a healthcare provider, and you should either audit it, which is costly and cumbersome, or you should be doing the payment. So it is, because the audit process is complicated, it is hard to assess how big such insurance fraud cases are in healthcare, but it is definitely a significant area where certain healthcare institutions could be significantly overcharging for their services. And of course, we are all getting impacted by this, because as a result, insurers are also needing to charge more for their services, and we end up paying the result of this specific case of fraud as the people who are purchasing that type of insurance. And here the important thing is to make these these interventions look as realistic as possible. And over there, again, machine learning is sadly, we are talking about ways how machine learning can help fraudulent activities, but it is definitely a case where you can personalize the interventions that have been performed on a patient to make them look more realistic, and as a result have a lower chance of getting an audit on your organization and be able to profit more easily from this activity. And of course, when we start to talk about how to resolve such cases, we will also talk about machine learning.
Well, let's stick with this example for a minute and see how deep we can go on it. Not technically, but just kind of operationally how this looks. So this is an insurer.
It's a person that is
a person. Okay, so not a company. So it is a person through their insurer committing fraud against the insurer. Yeah. Okay. So it's directly to the company. So what? I guess so. Are they? How are they? Are they changing their medical record or how? I guess that's what I'm trying to figure out. Where's the wrong information coming from and getting inserted and therefore having to be
one source. Yeah, of course. So one source is the healthcare provider. So the healthcare providers or the employee working at the healthcare provider could be adding additional charges on top of the insurers, whatever therapies or interventions that they received. So here, the healthcare actor is gaining at the expense of the insurance company and the person who was insured.
Nice. I suspect there are cases where if the insurer doesn't pay, then the then the insured ends up paying directly for all those extra costs, right?
I mean, even if nothing gets paid by the insured person, then the cost of insurance goes up for all of us because the insurance company has paid more than it needed to. And this, of course, changes their how they price risk. And as a result, it impacts how they price their premiums. And as we become new customers or as we continue our relationship with the insurance companies, we end up paying more in terms of our insurance premiums, just because some of the patients at some of the healthcare institutions are getting overcharged for the services that they receive.
And do you know if some of that is automated? So I'm thinking of the provider. They have some medical system that they use to generate the reports and do the billing. And are they automating the insertion of we ran a blood lab, or we did this analysis or this assessment that takes time and money, and therefore that's an added expense on the invoice that we're sending to the insured, or is it a manual one by one, or what do you know?
And so the automation is not something that I know of. It is more likely to be an individual person at the healthcare institution that is possibly somehow incentivized by what they are charging to the patient, or it could be done in short, somewhere in the healthcare organization or the healthcare organization itself. It doesn't have to be a massive hospital. It could be a private clinic, and the doctor in charge, they could decide to include some interventions that they haven't taken place. Whether there are actual cases that use automation in such a process, that I am not familiar with, but in short, it's definitely possible. but manually is more likely to be the case. And then, of course, there is the view of the healthcare provider, and there is the view of the insured company. It's insurance company. I mean, it's quite hard to prove that actually fraud has taken place, but there are estimates that a significant number of fraudulent cases are happening.
Yeah, and maybe we'll come back to that. So let's shift over to a world that you lived in for quite a while. So the financial services world, where I suspect there is probably some automation, and it may not happen. Well, maybe it happens internally by internal actors, but it's probably driven from external, and probably a lot of automation there. So maybe a different view. Can you describe some cases from a financial services perspective that we're seeing?
Of course. I mean, this is a very common one, but one complicated thing is to transfer large sums because it will of course get flagged and so on. So if you want to, I mean, if you have these illicit gains that you want to transfer to another party, making it through smaller sums that are transferred through various actors could, for example, fool old rules-based systems that were just relying on transaction amounts and also relatively simple network relationships. But by adding, of course, more rules to their rule set, this is something that banks have started tackling even with rules-based systems. But then, I mean, actors that want to do such illicit transactions, they are just they can definitely rely on automation and rely on having more accounts and doing account takeovers. And this is, of course, another type of fraud to be able to facilitate their flow of funds. For example, when it comes to taking over accounts, that's another type of fraud where they are providing wrong information to the bank to take advantage of some of the security flows and to get access to accounts that do not belong to them. Or, for example, another type of fraud is related to transactions where they are having complicated models and a number of actors and number of transactions to be able to bypass getting flagged. And I mean, we have discussed a bit things that are in let's say individual levels, but then also in if you think about sanctioned entities and nation states, over there as well there is significant incentive to bypass sanctions, and using simple rules-based controls where you are looking at the country of origin and trying to find it with certain keyword combinations, etc. And similarly with names of entities. Let's say my company's name is Gem Incorporated, Gem Inc. And then like if you are not catching companies that are of similar names, I could introduce typos in the process, try different company names, and try to, in short, get my invoices, get my transactions approved, and as a result bypass sanctions. And this is an area where of course even nation state actors can invest quite a bit of resources to make all parts of the transaction more difficult to catch. They could be working with the amounts, with the number of transactions. They could be working with the different parties involved, with the names of the parties, with using shell entities, etc. They could create a complicated and hard to identify paper trail, and as a result avoid being identified as the benefactor from that transaction. So there are different levels of complexities when it comes to dealing with entities or individual that perpetrate fraud.
Yeah, we just crossed over into supply chain now.
Yeah, definitely,
Super complex environment there. So, I mean, as you're talking, I'm envisioning this world where, I mean, if we look at weaknesses and vulnerabilities in hardware and software, there are sites one can go to look up, all right, which version of this IP camera, security camera has a weakness, default password that's hard coded, and we know what it is, and that can be exploited, right? So somebody, bad people, good people, that pulled this information together, made it public, and tools and cyber criminal services can use that data to conduct fraud or conduct cyber attacks against those devices and applications that I'm referring to. Is there such a world for fraud in terms of the rules banks use? I'm envisioning this database that says, here's the general scope of, if you're coming from here and do this transaction amount from this device on this system, it's going to get flagged. But if you cut the threshold here and you do it from a different location, you're going to get through, right? So kind of that open source intelligence. And then selling that and selling services that use that intelligence. And I'm kind of leading us to data, right? Which then ultimately leads us to the algorithms for doing bad things and the algorithms for hopefully protecting against them. But let's start with, do you know if there's a world of, we call it OSINT in security, open source intelligence for that type of data, the workflows in the business?
I think the OSINT data here isn't as powerful as the one in the cybersecurity world, where you have certain software and hardware limitations. Because first of all, there is some obfuscation, and the rules-based processes are no longer in place. So it's a bit of a harder challenge. You look at a bank and you don't know. I mean, you can put some effort, you can figure out which vendor they are using, but it is, let's say, not so easy to identify. These are internal systems that do not leave so much digital fingerprints on the web. So, but of course, you can working with internal resources, etc., you can identify the software being used. But then the rules-based systems that I have mentioned are like something of a relic. They were around 20 years ago, maybe 15 years ago, last being used. So all of the modern institutions now use a combination of machine learning based approaches and some rules based approaches, or completely machine learning based approaches. So it is hard to have these long lasting tricks anymore. However, I believe, if you search for these strongly enough, I'm sure on some with Tor, I'm sure you can find some channels where people are discussing their successful exploits and then learning from one another's knowledge. But it is a bit harder to reproduce compared to the software or hardware world, because I mean, these algorithms are also constantly learning, and then once one type of fraud has been discovered, then it's going to get caught across different institutions that use the same software as well. So it's a bit less straightforward, and I would say it relies a bit more on creativity versus something like looking for cybersecurity flaws in a company's attack surface, which you could just do with some off-the-shelf tools even. But here it's, let's say, a bit less straightforward.
Yeah, I can see that. I'm also picturing maybe kind of an e-commerce ecosystem where there's an application that uses a payment platform. I should say payment processing system. So an e-commerce site that uses a payment platform that uses multiple payment providers that connect to multiple credit cards, and there's a lot of players in that chain, and some may be a little more prone to letting transactions through, let's say.
Indeed.
Yeah.
Of course, because everything is a trade-off in this business.
Right.
Stopping transactions also has its own trade-off. E-commerce companies don't like it, of course.
Yeah. So the higher threshold fraud providers, if you see that one there, then target a different e-commerce system. Well, go ahead.
No, I was saying yes. Absolutely, you can increase your chances of getting through, but then not as guarantees as attacking an old version of a software. But still, yes, you can of course increase your chances.
Yeah. Well, let's talk a bit now about I don't know, maybe we haven't really gotten into where AI may be used on the attack side, and then we'll go inside and talk about how to spot stuff.
Yes, on the attack side, depending on the type of attack, doing it at scale can be definitely facilitated with machine learning, and it also depends on the results of getting caught by the system. While some types of fraud have significant consequences when you are caught, some types of fraud, like for example, credit card fraud, you could have scenarios where you can do and get caught and still get away without being identified. And in such cases, machine learning makes sense, where the cost of a mistake is relatively low and you have high chances to try different approaches. But I'm much more familiar with its use on the defensive side, because on the attacking side, the players, let's say, disclose a bit less or disclose a bit more with the people that they work with. But on the defensive side, it's definitely the tool to go. Just because if you look at any of the domains that we have discussed, whether it's ads, whether it's financial transactions, know your customer, know your supplier, any of these processes, these are extremely high volume processes, and there are complex ways that fraud could be happening in these processes, and as a result, definitely manual work, it's just impossible to deal with all the cases. Rules, as I mentioned, they are quite a fragile approach and hard to maintain approach. Therefore, since the past 10-15 years, machine learning players are playing an increased role here. And some of the interesting, from the benefit side, of course, having less cost and having a potentially higher rate of catching fraudulent cases. These are of course clear benefits. And if you think about the data sets that you can train your machine learning bots on, and if you take into account the case that these models can continuously learn as your analysts identify new cases, this is just a much better way to deal with fraud. And of course, it comes with its own costs. This time, instead of paying for a large worker force, you are making that a bit smaller, but then you are also, of course, paying the companies for the services in identifying fraudulent use cases. But overall, companies are able to both reduce the rate and also have less costs and more, let's say, stronger systems for catching cases of fraud, because this includes not just everything that has happened in the past, but machines can identify those patterns in ways that we may not be able to. And for new types of fraud that come up, they could see parallels, and then they could identify even new types of fraud. So compared to a rules-based approach, you have significant more benefits in such a case. But of course, it has its challenges. First of all, the model needs to be trained on your data, and you should, of course, be watching out for model performance decay. I mean, this is a general issue in machine learning. Models that start extremely well can see their performance degrade over time as as the people committing fraud get smarter, as your input data changes, etc. And but if you manage to have the model trained well for your specific transactions, and keep on measuring the success rate, and also take into account how much effort you are putting in dealing with false positives, etc., and make sure that the model performance remains at best practice levels, then there's definitely significant value to be generated by this approach.
Yeah, so much in there. And at the beginning of that, I was just thinking business email compromise, where it may not be an action by a fraudster directly to an entity, but through a quote unquote trusted source.
Mhm.
So an email going to an employee saying, I'm the CEO, transfer this money for me, is fraud, right? And so AI, and certainly generative AI, can help craft some of those emails,
Definitely.
learning from CEOs' previous emails, perhaps. It's not hard to get into an email system and collect emails like that. So that's one use of AI. So which makes me wonder. We're talking about scale here, right? The scale of business processes, the scale of systems, the scale of transactions. Uh, all of that makes it hard for people to keep up, which is where technology and things like machine learning and AI come in. And it makes me think of, in the security world, we say you can't protect what you can't see, which means you have to have an inventory of all your stuff, which never happens. And if you do it once, it's changed tomorrow and it doesn't look
Indeed.
the same, or it's irrelevant at that point. So in my mind, the assets and the discovery process is the data, right? And the documentation or the knowledge of how the processes on top of that data are supposed to work, so that you can then write some rules that say, well, in the old days, write rules. In the new days, I don't know. That's kind of what I'm going to. What do we do now? Is it still rules in the system that's fed into the algorithm, or do we write natural language? Don't let transactions of this size, and do we create the stuff in that way? Or tell me a little bit about how we go from discovery to actual creation of something that can detect.
Of course, I mean, one of the common approaches is to use a supervised machine learning approach, where what you have examples of historical data that includes, of course, all normal cases that weren't identified as fraud, and the cases where you are sure that they are fraudulent. And then, instead of prompting or giving any input to the machine, that this data becomes the input and source of the machine learning. So looking for patterns of similarity between the fraudulent cases, the machine learning model can make predictions about new cases that it sees. That could be because they are similar to the old ones, or even though they are not similar, there is some similarity that the machine can pick up. And this technology, the way it works for the past 10-15 years, the models have been using, of course, constantly updated data, constantly improving themselves. And an important metric that companies are working to lower is the false positive rate, because with machine learning as well, you are going to get quite a few cases where it's not a fraudulent transaction, and a human needs to take the time, take a look at the transaction. And I mean, it's the nature of the fraud management work. But that metric is the one that companies are putting significant effort in reducing. But of course, like not all types of fraud are really that straightforward. There are new types of fraud emerging, like you mentioned, using large language models for email fraud. It's going to be a new challenge for pretty much any company, not also just in the, and making the spam systems more vigilant, educating employees. This is a cybersecurity challenge. But in short, with these new technologies, indeed new challenges are going to be coming up. But we need to keep on identifying the new types of fraud and educating the models, training the models so they continue catching them. And over there, and the fraud detection software vendor ecosystem has a lot to do. They need to be coming to their clients with these, let's say, new. It's not really a new capability, but these, let's say, expanded detection models, so they can be rest assured that their systems are safe.
I love it. And as we wrap here, I want to maybe close with kind of full circle back to the human element here. And two parts to that. Let's look at it from two different teams collaborating with each other, security and fraud. Because I think there's, whether, I don't know how much there is now, or if they're completely separate teams. There's certainly overlap in some organizations, but your view on the need for increased integration and collaboration of those two groups, if you think there is a need for that. And then the second is the fraud team themselves looking at AI-enabled technologies. What do they have to do in their mind to kind of prepare for that? So the first is the collaboration of security and fraud teams and what that looks like, and then things AI or fraud teams can do to prepare for AI-enabled world.
I think the collaboration is definitely a no-brainer, given that the fraud teams themselves are now relying on quite a bit of software systems, and the security of these systems are paramount. So if your fraud detection system gets compromised, of course, that's the worst possible thing that could be happening. And as these systems get more complex, that's something critical, because for example, back in the day when you had a set of rules, the system was, it was hard to maintain, but it was, a set of rules. While now, in some cases, you have a black box model. In some cases, you have a model that offers you some explainability of why it chose this case, or, of course, in the best case, a full explanation of why a certain case was chosen. So in short, you could be at a case where you have less visibility into how the model works. And then, of course, this means you have less transparency about how healthily the model is performing. And the security of these systems, the communication of these systems with your bank's internal systems, these are extremely important aspects. And as fraud detection becomes more machine learning driven, I think security teams need to be more involved to make sure the integrity of these services. And when it comes to using machine learning, I think this is something that most institutions are starting to get used to. I remember the previous machine learning wave, like 6 years ago in 2015, 2016, there was this nice graph of CEOs mentioning AI in their in their analyst calls. So with quarterly reports, etc. They talk about their business environment, and then there was this graphic where the number of mentions of AI is like going through the roof. And back in 2015 or 16, I forgot the exact year. And then some of the systems that we have discussed, these, for example, supervised machine learning systems that catch fraud, that were a part of that wave. And now that they got integrated into the bank's workflows and they're operating fine, we don't even really see them as machine learning so much. It's like, bank systems, it's fraud management systems. But then you get a generative AI system where you can prompt and it gives you a video. That is AI. There's a nice saying by a computer scientist that says, if something works, it's no longer AI. And so I think, especially given the hype cycles in AI, it's quite true. Generative AI is quite an important part of AI, but it will definitely not be the last wave of AI. But it is going to get integrated by attackers. It's going to be used by companies in their defense as well. For example, we have mentioned things like transaction screening for sanctioned entities. I mean, that's an interesting use case for large language models. If they can go through all of the transactions, and this is not just a network problem, also the names in the network may not be matching the exact names of sanctioned entities, etc. So language understanding also plays a role, and these models could be creating interesting benefits there. And I think what's important for the business team is to definitely have an open mind and a fast experimentation mindset. When you work with any enterprise company as a B2B vendor, and I had experience with this, you are looking into, even in a POC, like 3 months, 4-month cycle. Of course, vendors want to reduce these time periods, quickly show benefits, but then how are you going to get the data? How are they going to ensure that even if your data get leaks, their data will not get leaked? And then, how are you going to show the results? How are you going to access systems, etc.? There's quite a bit of challenges in adopting new machine learning solutions in enterprise. But there are also some emergent solutions. There are technologies like homomorphic encryption or synthetic data. So you don't have to share your data to be able to see how a vendor is going to perform given your data. So in short, you could build a sandbox environment, experiment with new and upcoming companies, see how they resolve your fraud-related challenges, and then be able to relatively quickly identify what are the new trends in this field and adopt them relatively fast, because you have had a chance to, at let's say low cost, try different solutions and build enough confidence that, let's say, one of the solutions you tried is higher performing than your existing solution. Then you could of course, changing things in production takes significantly more time, but you could incorporate it into your plans. But instead of this, most of the time, what we see is that companies take significant time in running POCs, identifying the accuracy of solutions, and it takes months of investment, and then the result as well. Actually, our current solution is performing better than this one. So getting into a mindset of continuous improvement and experimentation, I think, is going to be helpful as new forms of fraud emerge and as new capabilities emerge on the side of these fraud detection companies.
So teams can't be afraid, shouldn't be afraid. I think that it's kind of reinforcing the quote from the scientist, where if it's working properly, AI doesn't exist, right? So
I mean, it's not
it's never
AI.
going to work properly. So there'll always be AI.
Exactly. There's always going to be some new and
That's
shiny
right.
AI that's gonna do things a bit better, and we'll call that thing as AI. Exactly.
It'll point out the flaws, and then we'll need it some more. So
Exactly.
never ending circle. Well, listen, Jim, it's been a pleasure chatting with you, and great to get your insights. I love that you have the history and all those different roles in financial services and in the analyst role and in the GSI role. You kind of have a very broad picture of all kinds of things here, and I'm grateful to have you on the show today.
Same here, Sean. Thank you very much for hosting.
And thanks everybody for listening to this episode of Redefining Cybersecurity here on ITSPmagazine. Hopefully Jim will share a few resources with us to help you keep learning after you listen or watch this episode, and stay tuned for more. So thanks everybody.
Thank you.
We hope you enjoyed this conversation. If you learned something new and this story made you think, then share ITSP Magazine with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our columns. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.